Welcome to another Ultralight Airplane Design video from the Ultralight Airplane Workshop. In this video, we're going to do something a little bit different. Now, so far, we've been working on simple design stuff using Dan Raymer's book. But I wanted to try to do a little testing on this airplane. And so what I've decided to do is put the specifications for this ultralight airplane, the UWS-4 is what we're calling it, into a flight simulator and see what we can find out about it. In this case, what we're using is X-Plane 11. Now, in this flight simulator, the flying model is completely separate from the visual model. I've only entered the flight model, which is why it looks a little bit crude. You can see here at the top of the fuselage, it's in very crude sections. And back here on the top of the tail, I don't have that flat section like I have on the UWS-4. It's just because it's a little bit difficult to put that in there, so I didn't bother here in the flight model. And let's look from the back end. You'll be able to see there's a gap here on the winglet, which wouldn't be in a display model. In a display model, it'd be clean, it'd look smooth, and we'd have paint on it in various colors. So this is strictly the flight model. But I have all the most important flight information on here and configuration information. For example, I had the flaps. So there's the flaps here. So we have center section flaps and flaps on the first half of this outer span. We have the ailerons. You can see those go up and down. Back here on the elevons, there's elevator. Let me do a little rudder here. There's the rudder. So what I'm using here for control on this airplane, I have a throttle from Thrustmaster, and I have a joystick from Thrustmaster, and I have foot pedals that are Thrustmaster. So that helps me a lot in control. I've tried flying with the keyboard before, and it's just too difficult. And here in a little while, I'll show you moving the throttle around and probably show you the rudder pedals moving around. Let's just do a quick run around on the airplane. So I got the 3-bladed prop. I tried to make it as close to the ultra prop as I could. And to rotate that propeller, I'm using a 20 horsepower engine. I got the twin tail wheels. I got the booms roughly like they're going to be. I've got this wingtip out here pretty close to right. I even have the fuselage fairly close to what I expect to do on the UWS-4. And of course the nose wheels. I might have them sticking out just a little bit too far forward, but I think it'll be fine for what we're doing. I've also included the correct airfoil on the wing and close to the correct airfoil on the tail. Now for the wing, as you may remember from a past video, I'm using an airfoil developed by one of my patrons, Keith. Keith, thank you very much for this airfoil. Now I'm using an airfoil on the tail on the actual UWS-4 that comes back pretty thick, pretty far back, just so I can have a thick spar back here on the stabilizer. But for this airplane, I decided just to use an NACA 4-digit airfoil, the 0012, so it's 12% thick. Now something that's kind of neat, and I don't know if you can do it with other flight simulators, but with X-Plane 11, you can actually go into some of the developer settings and have it show you things like alpha and beta, so angle of attack, your yaw angle. You can have it show where your XYZ position is in space, latitude and longitude, but what I'm really interested in is thrust, so I can have pounds of thrust that's produced by the engine, and I can have lift and drag. So I'm going to be looking at this while we're flying. Now something that I have to do, which is a little bit annoying with X-Plane 11, and I believe it's changed in X-Plane 12, is every time I bring this airplane up, I have to go set weight and balance. So let's do that. So I'll have a full fuel load, that's 30 pounds, that's 6 pounds per gallon. I'm going to leave the center of gravity roughly at that 25% chord of the wing, and I'm going to set the payload up to... I'm going to set high enough that we're about 475 pounds total weight. So I'm adding in 191 pounds. Now this is my first time ever entering an airplane for X-Plane 11 or any flight simulator. So it's very possible I've made some mistakes some places. In fact, there's something odd that's happening with another display I'll show a little bit later. Now the way I entered this airplane is with a program that's associated with X-Plane 11 called Airplane Maker. Let's take a really brief view at that. So here is the airplane already entered into Airplane Maker. But what you do is you come up under this standard menu, and there's quite a bit of stuff that you can enter. Viewpoint is the viewpoint from the pilot. Limits are the limits of the airplane, like the load limits. You can have a 2D panel or 3D panel. I won't really get much into that, although we will be looking at just the 2D panel here in our test flight. You can enter your engine specs, various other systems of the airplane, enter the wing information. So that's going to be things like the chord, the spans, the dihedral. Let's take a quick look at that. So there's various wing sections you can have, or separate wings if you want to. Wing 1, Wing 2, Wing 3, Wing 4. You can have the horizontal stabilizer. You can have vertical stabilizer 1, vertical stabilizer 2. What I did for the UWS-4 is I actually did horizontal stab is the entire, you can see this dark section here, is the entire slanted part of the V-tail. And then V1 and V2 are these vertical parts of the V-tail. So V1 and V2 do not have movable surfaces on them, but the V-tail does. And by the way, something that's really nice about PlaneMaker is you can set it up to move your controlled surfaces as you're building and specifying your airplane. So if they start moving, you know, you've at least got them set up so that they're in the right place. You can see the flaps moving here. You see the ailerons moving. And in fact, it's inputting both rudder and elevator here. It's just a little bit difficult to see. And of course, you got the prop rotating. And just quickly get through here, you can have some miscellaneous type wings. So you might do something like struts, some streamlined struts for that. If you have engine pylons, those can be treated just a little bit differently. The fuselage, miscellaneous bodies. Now for the pod here that the pilot sets in, I use fuselage. For the booms, I used miscellaneous bodies. You can have engine nacelles, you can fare your wheels, the geometry for your control surfaces, landing gear, and then weight and balance. We're not going to get into specifics here. This really wasn't a tutorial for X-Plane 11. I just want to do a little test flying with it. So let's get back to the simulator. Let's talk really quick about the 2D instrument panel I put in here. I didn't put in an actual real instrument panel. I just put in some information, rough information, just to get me by while I'm doing some flight testing. This top left one is our airspeed, indicated airspeed. This top right one is our vertical speed. Now this is in knots here for our airspeed and feet per minute for our vertical speed. And then this one down here is our propeller RPM. I also have several different views set up on the keyboard so I can get to them quickly. We got this rear view so we can see what it looks like flying behind the airplane. We have this cockpit view. We have a view without the cockpit. And then I have like a left wing, a right wing, looking back to the left about a 45-degree angle, and to the right at a 45-degree angle. Now, as you can see on these outer panels here on the wing, they're at a pretty significant dihedral, and that is a result of flight testing. When I was doing my initial testing, I originally had a dihedral of 5 degrees, and we figured that out quite a while back using Dan's book. But of course, Dan's book is assuming that I was using a regular configuration for the tail, a horizontal tail and a vertical tail. But of course, we have an inverted V-tail here. Well, this inverted V-tail has anhedral, and that is unstable. So I figured I would probably have to increase the dihedral on these wings to counteract this destabilizing anhedral on the tail. And it turns out I did have to do that. And in fact, at about 10 degrees, it was kind of neutrally stable, just barely stable. At 12 degrees, around 12 and a half, it seems to be stable enough. It's still pretty close to neutral, but I didn't want to do a whole lot more increase in that dihedral. So that seems to work out pretty well. I've also changed the angle of incidence of the wing. I've reduced it from 5.5 down to 4 degrees. And doing that, I was able to leave the incidence of my tail at about 0 degrees. So that gives me about the right amount of pitch stability. But that means that when we're flying, the angle of attack is about a -0.5 degree, roughly. So that actually gives the tail about a -0.5 degree of incidence. Negative -0.5 degree of incidence. I've also put a little bit of permanent trim here on the vertical parts here on the tail. And that's because the torque of the engine was causing a very slight left roll to the airplane, and I countered that with a little bit of right trim on these vertical parts of this tail. So those are the changes I've made so far on the airplane based on what I've learned so far in this flight testing. Well, we're just about ready to start our simulation and doing our flight testing. Let me go over the things I want to test. First thing I want to test is what is our maximum level flight speed. Then we'll go over our stall speed in the clean configuration, which means flaps up. Then we'll do our stall speed in the dirty configuration, which will be flaps fully extended. Then we'll do some stick slap tests, and we'll talk about that a little more when we get closer to it. And then offline, I'm going to do some lift and drag tests and see what we can come up with. So as you can see here in the lower left-hand corner, I've put a video for the stick movements that I'm going to be putting in here, so you can see those. The video on that is just a little bit delayed, but it's not too bad. And then on the floor, I have my rudder pedals. So I can do left and right, and then brakes. I have individual brakes. So you'll be able to see me do those. And again, there's a little bit of delay on that video. And I'm not going to give you a video of the throttle. That's not very interesting. So let's get started. So as you can see, I'm using the rudder pedals to steer with. Let's put them both on. Let's go ahead and go up to full throttle and take off. I'm going to switch over to the cabin view. So I'm going to climb up a little bit. Actually, we don't have to climb too much, but I'm at full throttle now. So at the moment, we're climbing at about 900 feet per minute. Okay, that's enough. Let's go ahead and level off. I'm going to try to reduce our climb rate. Okay, that's good enough. Okay, I'm going to give it full throttle now and try to keep from climbing too fast. I'm going to have to push forward on the stick just a little bit. I'm not going to bother with trim just yet. So what I want to do is to get that vertical speed indicator fairly close to 0. Keep it there while we're climbing. So we've already passed 59 knots. We're still climbing a little bit. Push forward a little more. There we go. Now we're pretty close to 0. So you can see we're still climbing. We're speeding up still. We're at about 65. About 66. So it looks like our maximum low. Let's see, I'm diving just a little bit there. Let me come back up. There we go. So I think our maximum level flight speed with this configuration is about 67 knots, it looks like. Around in there. That's certainly more than the 55 knots that we wanted. So up here in the upper left hand corner we have some drag numbers, and I'll try to zoom in on that so you can see it, and we're right around 41 and a half, something like that, pounds drag. Now that's less than I had anticipated. I had anticipated somewhere up around, I believe it was 52 pounds when we did our calculations before. The drag on this airplane currently is much less than it was on our estimations for the UWS-4. So we'll have to work on figuring out if we need to change this model a little bit, or were our estimations too high. Something we're going to have to work on. Alright, let's back off. Our next thing on our list to do is stall speed clean. So let's start reducing power. I'm just going to go ahead and pull it back to idle. And I'm going to have to try to keep from losing altitude a little bit. We're slowing down. I'm pulling back on the throttle now. I need to pull back more. We're down 32. Still losing altitude. 28, 27, 25, 24, 23. Ah, you know what? I forgot to do something because that was way too low. Let me fix a little something here. What I had forgotten to do, I'll pause the simulation here, I had forgotten to set the weight and balance. Let me do that. I'm going to do a full load of fuel, and I'm going to get the gross weight up to 400, and that's 78 is pretty close. That's a 170 pound pilot, 254 pounds of empty weight, 24 pounds for a parachute, and 30 pounds for our fuel. All right, now let's resume and try this again. Let's go back up to speed. Oh, looks like our engine failed. There we go. Now we got it. Okay. Now let's see if I can keep that pitch up or keep from losing altitude quite so fast. There we go. 37, 32, 29, 28. I'm having a little trouble. I'm trying to use the rudders to keep us from losing a wing. Okay, that wasn't very definitive. Let's try that again. So it looked like it was just under 28 knots that we had that stall. Let's try it again. Let's get back up a little faster. All right, here we go. I'm going to pull it back to idle. $28, a little under 28, I believe. Now I'm just going to hold the stick back. Ooh, I'm having a little trouble here. Woo! Alright, that's enough of that. Okay, I'm going to try one more time. Let's climb up a little bit, get a little altitude. The simulator actually provides another feature where you can actually graph the various parameters for like speed and drag and lift. And I'll probably use that on a future test and see how that works out, but I haven't tried it yet. So I'm expecting the stall in the clean configuration to be around 28 knots. So let's try it one more time. Around there. So it's not too far from what I expected. Alright. Let's get going again. We'll get a little more altitude. Okay, that's good enough. Now let's go to the rear view so you can see this happen. So I have a little toggle on my throttle for dropping the flaps. So let's go ahead and do that. So there's 5 degrees, there's 20 degrees, and you can see it pitched down when I did that. Here comes 40 degrees. And it pitched down not quite as much, but a little bit. Okay, let's go back to our panel. Alright, so we're already kind of slow. Let me pitch over just a little bit. Okay, we're close enough to 0 vertical speed. I'm going to start pulling back on the throttle. Now this has a lot of drag and it happens fast. Boom, 25. Let's try it again. Okay, here we go. As soon as we lose some of our vertical speed. So I got full throttle now, and what are we doing? We're just barely doing 30 miles an hour. We're still climbing a little bit. Okay, this is going to happen pretty fast, so let's try to keep an eye on it. Let me level out just a little more. Okay, good enough. Here we go. I'm going to pull back to idle. I'm going to lose our speed fast. 27.65. So it's about 25. So that's about a knot higher than I expected. I was hoping to be around 24. So that's not too bad. Well, what's next on our list? So what's up next is our stick slap. I'm going to get set up for fairly steady level flights. Let me do that. Let's get going a little bit. Or we need to take our flaps back up. Oh, let's let you see that. There we go. So all I'm going to do is get up to a speed where I can be hands off on the stick. You go just a little faster. If I have to, I'll put a little bit of pitch in, but shouldn't need to do that. It looks like I need to pull back on the throttle a smidge. Alright, that's probably... I'm looking at the vertical speed here to see if it's... Oh, that's a little too much. Okay, let me pull back just a smidgen. Okay, now as you can see, this vertical speed indicator is going up and down. We have this very long mode oscillation in pitch. I want to add just a little more throttle here, and you can see the nose going up and down. Now very slowly over time, this oscillation will die out. Okay, I'm going to add just a little more throttle. So as you can see, I don't have my hand on the stick at all right now. I still have my feet on the pedals. Okay, we went up to 30. Let's see what we go down to. That's close enough. We're close enough to 0 speed here. Okay, so as you can see, this vertical speed indicator oscillation up down is slowly dying out. And I did not do any trim on the airplane. So right now we're neutral trim. So that's what I want to have for the airplane. I want to be able to have neutral trim at my cruise speed. And 15 knots is roughly what I was hoping for a cruise speed. So that's not too bad. So we've almost had that oscillation die out. Very close. Okay, now we're going to do some stick slaps. So what we want to try to do is try to figure out how stable this airplane is when there's a perturbation. Whenever there's something like air currents or the pilot accidentally knocks the stick, will it recover from that and go back to a nice flight? So we are going to go back to our back view. And let's try pitch. Since we were just looking at pitch, let's do a slap forward and see what happens. So I'm going to hold the base so I can smack it pretty good. So I'm going to knock it forward and we'll see what happens. So we did not get any fast oscillations, but we now have returned back to our slow oscillations. So over time, this should die out. So let's go back and look at our panel. And I'm still using rudders to guide the direction of the airplane. Looks like I'm having to give it just a little bit of rudder. So right now the oscillations are pretty high. We went to negative 140. Now we're coming back up to about 110. Now let's see how far we go negative this time. Well, this time we only went to 170, so we cut that negative in half. And in the positive direction, we'll cut that in half roughly too. We went up to 60. Okay, so I like that. Now let's knock the stick back and see what happens. So I'm going to knock it backwards. So again, we didn't have any big short-term oscillations. We did go back to this long-term oscillation. Okay, now this is something I can live with. I don't mind having this long-term oscillation. I can fix that with a little bit of pitch input and knock it out pretty quickly. So I'm perfectly happy with that on our airplane. Okay, let's do roll oscillation. So let's go back and look at the back end again. So I'm going to hit the stick to the left, and I'm going to mostly keep the, in fact, I'll just take my feet off the pedals right now. And let's just hit left and see what happens. So it went to the roll and stopped. Now you notice there was a little bit of wiggle in the tail back and forth. Now let's see if we can come back to our upright attitude. Kind of wish I had a roll indicator here so we could actually see it on some numbers so we don't have to wait too long. So it does look to me like we're very slowly coming back to an upright position. Very slowly. So it's not unstable here in this roll. Okay, let's go back to vertical. Let's try a right slap. There shouldn't be any difference in that, but let's do it anyway. Again, you saw that wiggle on the tail back and forth. Now, it did not continue rolling. It stopped the roll very fast. So that right wing on the outer panels horizontal at the moment with the horizon, and it looks like it's very slowly, once it comes back up again in our pitch oscillation. Yeah, so it's very slowly coming back to upright. It's pretty slow, but it is doing it. I'll try one more oscillation just to see how much more it comes up. Yep, looks to me like given enough time, it will probably come back to straight upright. I'm going to go ahead and wait on this. Let's just see what happens. Oh, we're just nearly there. It's not too bad. Now we could make this come upright faster by increasing the dihedral out on those outer panels. But I can live with this. This is pretty good. Now I'd rather not increase that dihedral on those outer panels if I can avoid it. Looks like we're flying in a fairly straight line. It might be coming back to the left just a little bit. Yep, we're very slowly starting to drift to the left. I have some fixed pitch back here on these vertical parts to try to counteract the torque. Looks like I need to add in just a little bit to counteract that. I've added in some, I need to add just a little bit more. Looks like it's very slowly increasing that rate to the left, because you can see this land going by to the right a little bit more. Looks like, yeah, it might be as much as it's going to do, so I do need to add a little bit more trim here. Okay, next thing to do is the rudder pedals. So I'm going to leave my hands off the stick, and I'm going to put my feet on the rudder pedals. Let's try right rudder. So I'm going to hit right rudder hard, let it loose quickly, and see what happens. Here we go. So there was a big swing on the tail. It also gave us some right hand roll. So there's some oscillation here in our rudder ping or rudder slap. It wasn't long, but there was a little bit there. But there's no long-term oscillation there. And we're very slowly coming back to upright again. Let me go ahead and just fix that. Now let's try left. Shouldn't be any different in the left, but let's go ahead and do it. So there's that short-term oscillation that dies out fairly quickly, about a 3-second, maybe a 4-second oscillation it looks like. And then we're very slowly coming back to upright again. Okay. So that's good. That means we're fairly close to a stable airplane. It will fly itself hands off, except for that very slight left yaw as we're getting to a fairly stable upright condition. So that's something I'm going to have to fix. Very nice. Alright, now something I fixed just before we did this test is I increased the pitch deflection for this V-tail a little bit and reduced the rudder deflection. I thought the rudder was a little bit too powerful when I was trying to do a forward slip. So let's go ahead and do a forward slip again. So I'm going to pull back the throttle. So let's do right aileron and left rudder. A little more, a little more. Okay, the rudder is still more powerful than the aileron. I'm going to have to take off the ailerons just a little bit. That's okay, but not bad. Now I have I still have some directional control in the forward slip just by changing the rudder. That's not too bad. I can live with that. That's better than it was before. Okay, very good. I like that. Okay, let's climb back up. Oh, I just noticed something I had never noticed before. Look at the middle of the propeller there. So right now it's fairly clear, but look what happens when we come toward the sun. It's like there's smoke or mist coming out of it. Had not noticed that before. Okay, now the next test I want to do some lifted drag tests. I'll tell you what I'm going to do, but I'm not going to Well, I guess I'll give you one example of it. Let me climb back up here. Alright, so let me bring back the panel. Now, as I showed you before, I can look at the drag that we're producing on the airplane. So what I want to do is get in a stabilized decline. I'm going to pull back the engine all the way, and I'm going to pick a descent speed. Well, heck, since we're going this fast, let's just go ahead and do it. So let's look at 50. So I might not have enough room here. 50. Alright, that's fairly stabilized. So what I want to do is read the thrust right here at 49. And then what I want to do is climb up and pick another speed, like 45, 40, 35. And by comparing speed and thrust and making sure that I have fairly stable descent, my lift will be 474 pounds or so. I can actually calculate the lift to drag and figure out what it is for this configuration of the airplane. So I'm going to go ahead and do that and come back momentarily. Okay guys, I've gone through and done some testing, and it looks like the least drag I have is at 48 knots. I expected the least drag to be at somewhere around 40 knots. But let's go ahead and assume maybe it's right, and we'll do the calculation. So that drag was 37.7 pounds. So assuming we had 478 pounds earlier when we did our weight and balance here in the application, that comes out to be 12.6 for lift to drag ratio. Seems a little high, but for the moment, it's kind of interesting. So we'll go ahead and live with it for now, but we'll see. Maybe it's right. Maybe we need a little more drag, and this lift to drag will drop down a little bit. Well guys, as the sun sets in the simulator, we are coming to the end of our video. I've learned a lot using this simulator. I'm very excited about some of the changes I've made. I kind of anticipated having to make them, and it looks like what I anticipated is matching up with what the simulator is telling me. So that makes me feel fairly good about what we're doing. I don't know when we're going to get back into the simulator again, but it could be the next video, or it might not be again. I don't know. We'll find out. Well guys, thanks for watching. Till next time.